Alright, we are still in our week 3 packet. We are looking at this page, understanding representing a situation with different expressions. This page is all about knowing what is the question asking. So we're going to read the problems, we're going to talk through it, and fortunately for us, on this sheet they give us the expression. We're just trying to figure out what is it asking, what does it actually mean. So here we go. Number 1 says, goby fish and shrimp naturally live close together. A pet store is selling bags of goby fish and shrimp to aquarium hobbyists. Each goby fish costs $15 and each shrimp costs $10. Each bag has an equal number of goby fish and shrimp. Part A says, the pet store models the cost per bag with the expression X times 15 plus 10. Explain what this expression represents. So let's go back to the problem and figure out what it's telling us. Each fish is $15. Each shrimp is $10. So what if I decide I want 10 fish, but you want 15 fish? That's where this handy dandy thing called the variable comes in. That's why we have a variable. The variable is the giant IDK. Remember, we've talked about this quite a bit. So my explanation for this would be X is the number of fish. So what is the 10 and 15? 15 is the number of fish, and 10 is going to be the number of shrimp, or the cost of shrimp. So what we have in parentheses, 15 plus 10 is the number, I'm sorry, not number, amount. Let's say amount. Amount is more accurate. Of one fish and one shrimp. So the problem tells us that each bag has an equal number of fish and shrimp. So we know that we're going to add those two together and multiply it by however many we choose to get. So part B says, what other expression can you use to model the cost? Explain what that expression represents. On the sheet that we just did, we combine these. We used distributive property, or what I like to call our steak dinner. We've got X times 15 plus 10. If we steak dinner, remember this is the family. Whatever happens outside the family happens to everybody in the family. If brother gets a steak dinner, sister wants a steak dinner too. So if we're going to multiply X times 15, we get 15X, and we get 10X. And if we look, we've got X family and X family. We keep families together, so we have 25X. What is this actually telling me? This is telling me that I can multiply $25 times the number of fish I want. It's another way of restating this expression. It's all exactly the same. Alright, number 2. Miss Gandhi runs 1 mile each morning and 1 mile each evening. She also does 10 push-ups each morning and each evening. Part A. Miss Gandhi writes two expressions, 2 times m plus 10p and 2m plus 20p. Explain how each expression represents how much she exercises. What is the question asking? The question is not asking me to solve it. The question is asking me to explain it. Put it in words. What do these expressions mean? Well, we're going to use a little common sense here. M is going to stand for mile. She goes 1 mile each morning and 1 mile each evening. How many miles does she go a day? She goes 2 miles. She does 10 push-ups in the morning and 10 in the evening. We're going to use P for push-ups. Kind of makes sense, right? So how many push-ups does she do a day? she does 20 push-ups. So if I take 2, showing that she has 2 rounds of workout every day. She's got a morning set and an afternoon set. And I multiply that by M for 1 mile each time and 10 push-ups each time. That's going to tell me 2 times a day she runs 1 mile and does 10 push-ups. So 2 times every day she does 1 mile. And remember, I've got an invisible 1 right here. She does 1 mile and 10 push-ups 2 times a day. Right? Let's look at this one. The second one says 2M. How many miles did we say she ran? She goes 2 miles and 20 push-ups. That's it. That's it. That's all it means. Alright, let's look at number 3. Miss Gandhi wants to determine how much she will exercise this week. Write an expression to model this situation. Explain your expression. In a week. How many days are in a week? 7 days. So I know somewhere I'm going to have to use the number 7. So I'm doing everything for 7 days. So 7 times, what am I doing every day? Every day she's going to run 2 miles and do 20 push-ups. So for 7 days she runs 2 miles per day and does 20 push-ups. So this expression is this in words. Alright, last one. Number 3. Write 2 expressions for the perimeter of a square. Explain what information is in one of your expressions that is not in the other. Alright. So let's take a step back to 5th grade maybe. If we have a square, perimeter is asking for the outside. This is like building a fence around a flower bed. Perimeter is going around the outside. So what am I going to need to get perimeter? If the perimeter is, say, 2 feet, and I have a square, I know that the length of each side of my square is going to be 2 feet, right? So one way that I can get the perimeter is to say 2 plus 2 plus 2 plus 2, and that's going to give me 8. But that's so 3rd grade, right? We don't do that anymore. We're going to say we have 1, 2, 3, 4 sides. 1, 2, 3, 4 sides that are all the same length. That's 2 feet. And when things are smushed together, we know that means multiply. 4 times 2 is 8. What if? What if we decided to kick this up a notch? What if we decided that we were going to do this the 7th grade way? Still got my square, but I'm going to make it a little more complicated. Each side is x plus 5. Oh, does that really change anything? If one side of my square is x plus 5, does that really change what the lengths of my other sides are? No, it doesn't. Every length of every side is x plus 5. So one way I can say this is x plus 5 plus x plus 5 plus x plus 5 plus x plus 5. And I know all of my x's have an invisible 1 in front of them. So I've got 1, 2, 3, 4 x's. 1, 2, 3, 4 5's. It's going to be 5, 10, 15, 20. So I can shorten that to 4x plus 20. Well, that might work. What is the question asking me? The question is asking to give 2 expressions for the perimeter of a square. I can use this as one expression. This looks like a 7th grade expression. I think I want to use it. 4x plus 20. I pulled this number out of the air. I absolutely did. You can use whatever number you want to. But for my example, I'm sticking with this one. The second part of the question says write 2 expressions. So I've got to make another expression. Now, if you think back to the sheet we just did with factoring, I can factor this one. I need to know the numbers that make up 4 when I multiply. I've got 1 times 4 and 2 times 2. The numbers that make up 20, 1 times 20, back that up a little bit, 2 times 10, and 4 times 5. I'm looking for the highest number in both of these lists. That's going to be a 4. I'm going to pull a 4 out of this expression. So 4 divided by 4x leaves me with x. 20 divided by 4 leaves me with 5. That is an absolutely different expression. I'm going to use that one. So 4 times x plus 5. The second part of my question says, explain what information is in one of your expressions that's not in the other. This one is factored. This is showing I have 4 sides, and the 4 sides are all x plus 5 length. I know that you know how to do this. This is one of those pages that absolutely is looking for you to make a mistake, and you have to pay attention. What is the question asking? Remember, if you have any questions with this, let me know on Google Classroom, and I'll get to you. Love you guys. See you soon. Stop recording.